loose. Work there. And then just kind of lightly tight. Oh, cinch tight on the knobs.
But we'll have to put the. Are we touching?
Yeah, we'll do this is just test fit. Just test fit, and then you get it kind of rough size.
Sure.
And then just sort of snug tight, not super tight.
Okay.
And then we'll put the other two. So we'll have to use some tape around areas like that, but that's fine. Or not, we could just leave those open because they're kind of real. Okay. So then we just set it out. I like this bigger one. I kind of want one now. Doesn't need to be super tight just yet. We'll tighten it up when we get it on the door. That's just gonna hang there. I found you can kind of drape it on before you set it up to the average size, but I found it's just way more difficult to set up. And then you don't you just end up fighting with it. That's why I pre-size and then do it that way.
Yeah, we struggled last time.
Yeah. There we go. And then we're just gonna rough fit there, rough fit there. Yep, like good. Not bad, not bad. Okay, and then we can tighten up a bit on these guys, just a little bit, and then cinch them down with their little clamp. And then we get the cross pieces. Hey, look at that gap over there.
Going to be inside the building?
Yeah, we can be inside. Yeah. But we'll pressurize because we don't know if there's asbestos, so we'll push air out rather than pull the asbestos dust in with us.
Is it a common practice you always pressure it out?
What's that?
Is it a common practice you pressure it out, not pressure
If you don't know the status of the asbestos, yeah.
But for testing a new build and especially high performance,
Yeah.
you do both.
Yeah.
Take the average.
We need one down at the bottom. We may not need all three on this size of door, but we could put it in just for good measure, just for fun. Yeah. Let's put it in just for fun. I don't know if we actually need it, but over, I think this way. There we go. So it should hook in on the back and then on the front. They have numbers on them, but I found these numbers aren't always where you actually want to put it, just because some different doors, different shapes, right? And it doesn't really matter. It's just there to hold the door rigid. There we go. Okay, so we're tight, except for that corner, and we're probably not going to get tighter on that corner. Yeah, okay, good. I'll need this one. There we go. And that's not too low. Yeah, no, that should work. Okay, cool. Now we're ready for the low. Now, nice handle on it. I like that. There's all these new features.
Otherwise, they will not sell it.
Yeah, that's right. Okay, so now, because we're going to be inside, we do have to take a little bit of a guess about what range we're going to use. So I'm going to assume that this building is as leaky as it can be, and just take off the full ring.
Yeah, anyway, we are using just one, so it will be wise to take the.
That's right, and so we can always, I mean, if it'll send us a warning that it's too high, and we can always put more back on. But just as a start, it's pretty easy to assume that we're gonna be like that. So this is kind of like a hip maneuver. I usually put it on kind of my hip and then in the bottom and then around. Except messed up. We have to move that. Yeah. To that one, maybe even up there. That's probably good enough. There we go. Okay, so it should be hanging freely like that. And then the controls.
The spaces we're going to be interested in for thermal bridging are, I'm curious to know about any penetration through the walls that are here with the next suites. But, and you're going to thermal bridging all around.
Even if you're not
Yeah, you can just tell. But having the image saving it around it's so
table.
yes. But the leaks should be. Mark, did you bring your smoke with you?
Sure did.
Yeah,
I brought mini smoke and I brought big smoke.
Great. Yeah, that'll definitely show.
We're not photoelectric in here though, are we, for smoke alarms?
Good question.
Or do we have smoke alarms? Yep. Yeah. So, let's stick to mini smoke then.
Some smoke?
Not expensive.
Okay.
It's not wired to the whole building, I'm not worried about it then. It's just when all the fire trucks show up, and I have to explain to them why the building is so smoky and it's not actually a fire.
So, Mark, I will take your specification, which kind of smoke pencils you use.
So this is the big, we call it big smoke, and it's not even that big. This one, it's from Long and McQuaid. It's just a DJ smoker.
Yeah,
Okay.
yeah.
And then the same thing with this is just sugar-based
Yeah.
smoke solution.
Yeah, just same used in the parties.
Yeah, the little one I use is the Dragon, which RetroCheck sells.
Okay.
And this one we've heavily used. Ours is getting worn out. It's almost time for a new one, but it puts out a lot of smoke. It's like a vape pen.
If we use it here, then we'll know how exactly. to do it.
Yeah, I hope I have batteries for it, but I think we can use it. Should be okay. So this plug, that one looks sketchy, so I'm gonna put one in the less sketchy one. We'll see how that works. That's a fused power bar. So okay, so we should have you're into there, and then into your control unit, and then into this guy. And then you've got we've got yellow. Go. So we're hooked up on the fan, and then you should have a port in here too for your yellow hose connector to your DN32. Yeah. There we go.
And this one.
And that one. Okay. Yeah, that one should go into there.
So this is going to go in out, right?
It should be. Oh, sorry. Here. So we're on. It's all on control.
Yeah.
So it should be on control there, and I believe it should be in on that one.
Sure.
And then you should have a connector for this yellow hose to go into here somewhere.
Yeah,
Or
that's
a fuse. Where does it go into here? Where do we go? Oh, that's a coupler. We have. Do you have another yellow hose?
Yep.
Yeah. Okay.
Oh, yeah.
Oh yeah. There we go. Oh, there's this. Oh, so okay. So this is the standard control hose here. So does this fan hook up with a standard control control. It does not look like it, but no. Okay, so this is the, we call this the command cord usually.
Yeah.
And yeah, so that's the, so it should theoretically be yellow into here. Like that. And then yellow into this guy. Like that. They make it color coded for us. And where's the other red? Oh wait, I'm on the wrong side. Hold on. Short side. There's a short side and a long side. There we go. Short side goes to controller. That. And then they want, so they want, yeah, into the command hose. Yeah, so this is, but they show it going into the back of your power supply here. What is, we don't have that.
So, yeah, I think this doesn't match with this. So
No,
I
it
think
doesn't.
They have it for a common one.
Right.
So, but
So we're missing a yellow port here. The yellow port is the fan sensor. So we should be able to, theoretically, I think, connect this one here, like this,
yeah.
and then this guy into the
Out one.
out, and then actually I'm not sure we do need that one because that one controls. I don't know. Maybe we don't need this. Actually, you know what? Yeah, here we go. This is here. So it should be like that, and then we don't actually need that spare yellow. We can just do it like this, because that controls the fan speed. Yellow is the inside sensor in the fan. Red is our outside hose. So we'll shove that outside.
Just to get the pressure differential.
Yeah. And this one is supposed to be a little ways away from the exhaust of the fan, so it's not in the fan, in the kind of the prop wash of the fan. So I usually kind
It has
of
to far away.
pull it through and then give it a toss and make sure it's not like in a bucket of water.
Do you have some of those pressure differential manometers you install outside of the building? No?
I don't use those. No.
You just use this one.
Yeah, it shows up on here,
Okay.
so you can get that data if you need it, and it shows up in the software if you need it. So that's all tight there. That's tight there. Okay, good. Okay, so now we should be ready to turn on. And let's turn on here. We'll go through the fused thing just in case that's on there. Do we have an on switch on the fan? No on switch on the fan. Okay, that's new. And then on switch here.
Take out the cover.
Oh yeah, is there a cover? It's not here. It's so brand new. We still got a cover on it.
No, no. I.
Oh, this.
Yeah.
Yeah, the little finger cover on it. Is it not charged?
Yeah. So this one is, I think, for the charging.
It's the little USB. Do you have a little black USB? I've got one if you don't have one. Should be somewhere with your command cord
Yep.
stuff.
Yeah.
And then we'll charge it. We'll put it on the. It'll come to life pretty much right away when we
Yeah.
plug it in here.
Use our one. This is the one?
Yeah.
Yeah, that little. Yeah, that's
Yeah.
the one.
Let's open this one.
Yeah.
Because you
I'm just
want-
getting power for the computer here so we can charge it from the computer.
Okay.
And then do that. That's what we'll need for. Do we happen to know the envelope volume or the envelope area? No, it does, we don't 100% need it. Just it gives us some extra little results. So this is the fan tan. Okay. Are you guys using the fan test software with your gear, or are we just going to do it recording the numbers on your own?
Yeah, I think we can record it on our own.
Okay.
But, I don't know. Yeah, we have
so-
not used this yet.
This, so let's see if we can detect it. It's on? Not quite yet. Okay. So the reason we like to use this, and it comes with should come with your software, or with your package, is because we can get more accurate than manual recording, because you'll see a lot of variation, and so this will take all those variations and average it for you.
Okay.
And it's also a little faster because you can set it to go and it kind of runs automatically.
Okay.
And then, and if you need to test individual pressures, you can test kind of whatever you want, but it won't. We use it especially when we're doing builders, because then we can set it and it runs, and then I can chit chat with the builder and do my teaching while the thing is running, and then we can come back to it. So we're charging here now. It looks like we need a little more.
So they should provide a CD or USB.
It's just download off their website.
Okay.
I think it's just a subscription. There is a free version that should come with your thing, and then there's a pro version that allows you to test more than 3 fans at a time. So the free version only allows 1 fan at a time.
Okay.
And this is the pro version, and on this version we can do up to 6 fans. I'm just gonna wait a second for that to charge up.
No, it's downloadable, so I think we can.
Yeah, it's just off the RetroTech website.
You can do that, isn't it?
Yeah. I think I have some numbers which I can have license or something. Then
Yeah, they should have at least given you the license for the free one.
There's the calibrations.
Yeah.
So that's me in this.
This normally takes a minute or 2 if it's completely dead, so it should come up.
We have got a laptop dedicated.
Yeah.
So if you guys were outside for whatever reason, it's the red hose we switch between those two. And
So in any case, you do the test from outside because you don't have access to inside.
yeah, or the one I did yesterday was because inside was a dirty construction site and I didn't want to be in there, and so you just do it from the outside. It's fine. Yeah. Or at Charter Telecom, we had 1 fan up there, and so we were outside of that fan, but inside the other one, right?
Okay.
So you wire to, so it's just the inside outside port, and so you just have to switch that. Or this one will switch when we're we use this one at Charter Telecom because we're inside outside, right? So we don't want to measure the space we're pressurizing with a different fan. Come on. I guess just charge for a little bit.
But last time when we switched it on, it was already.
It was on? It was already charged? Okay,
Yeah,
so
I don't know whether it was. I think it was a different kit.
yeah, maybe this
The
one
other
has.
one?
Is it? Do you want to try your other one just to see if it has charge on it? This one doesn't seem to have charge on it. So this is. Oops, no, that was the fail test. Hang on a second. This one here. So this was a single fan test, and so when we run the auto software, it first populates the baseline for us, and then it starts going through the numbers. And so the nice thing is that we don't actually have to be at 60. It just kind of gets pretty close and then stabilizes there. And then so it's reading 58.62 and then it steps down on its own and gives us.
Then you extrapolate or interpolate it.
That's right. So the graphs it gives us, right? It gives us a nice standard deviation and a lot more data points than if we're just doing it manually.
So how long is the
But we don't
duration
have.
of
We
this?
have
About
the,
10 minutes.
We have the software.
Yeah.
We can download it free and use it.
Yeah.
And we can use it for multiple fans.
The free one, I know you can only use one fan. The one that's not free has up to 6 fans.
Okay. I'll check with them. Maybe we have bought it.
Yeah.
Check.
And it's nice. It gives you more error, like more different types of errors too, so you know kind of where your issues are.
At each pressure, it is 10 minutes you stay. and
Oh
you
no,
go?
the whole test is 10 minutes.
Okay.
So the baseline lasts about maybe 5 minutes, and then the actual test lasts about 10 minutes. So all in all, about 15, depending on if you switch ranges or not. And you can switch the range of the fan. So if you're down at the lower pressures, quite often we're switching down to a lower range, and then. So it allows you to be more accurate that way, because when we switch manually, the accuracy goes way down too. All right, we ready to go?
Yeah.
It is ticking now, so I wonder what's going on there. Oh, actually, I just saw a flash. Oh, see, something's wrong there. So that's flashing. So I'm not sure what that is, but something's definitely wrong there. May need to get that checked, or put it on a charger for a long time. That might be an issue.
Better just check it. If it is wrong, then we can get it replaced by them. Okay.
Yeah, Retrotech's really good about standing behind their equipment. So it should turn on by itself here. It should just turn on actually when you plug it in.
Yeah, because last time it was on, and maybe that time it was or new. That's why it was already charged and it
Maybe.
has lost the power or something. But
Yeah, normally with ours when we plug it in, it turns on, and it
Why
kind of
not?
is automatic.
Is the battery? Is there any battery inside?
Yeah, there's a little rechargeable inside.
Oh my god! I don't think it's missing.
or are we doing something wrong in plugging?
It shouldn't. That shouldn't have. None of these cords should affect its ability to turn on. This one will
Is-
cause it to
But
turn on.
last time, did you charge it from a computer?
No,
How did you charge it?
no, we didn't.
We didn't charge it.
We can. Yeah. So I suspect that either the battery is just very low.
Ah.
Yeah.
So let's put this one on. I've got a charging brick here, and while we're waiting, and
Probably you have to charge it previously.
Do I have
Last time you just charged on?
No, I think it was new, so that's why it was already having some charge, and the charge must have drained.
This is the right one. I can't remember if this is the right one or not. Yeah. So if we just give it a little bit of a charge, and while we're waiting here, and then we could do our prep while they're both charging.
Yeah, this one.
Oh, there we go.
Yeah.
Okay.
So maybe
now-
Something
something.
around there.
So we might.
Oh, it says that we have to press it, keep it pressed for 2 seconds.
Okay, let's try that. This one.
This one came
This one is.
already.
Yeah, this one's saying. came
Maybe
on, so
the charging method may
Yeah,
not be.
there might be.
It doesn't
might be
like
some
that.
issue.
Yeah.
Yeah, we might not be getting enough power through there.
Maybe the
So-
some of the USB port, the charging is very slow.
Yeah, let me reconnect here then. Here, let's go this way. And so if we come out and we do, leave that one. Don't step on it. We'll come this way. Come this way to it. What do we get? Yeah, see, that's that ticking. That's strange. It should tick after it's up and open.
Yeah. So yeah, last time we were using this one.
Yeah, we were using that one,
So
so we're
I
having the same problem with two. So it's probably not the device. It's
Yeah.
probably something we're doing here. And that one came on with what looked, I think, was a full battery when it came on. Let's try that again here. That looked like a full battery when we were. So that should turn on if it's got any charge.
The last
Maybe it
time,
was-
the moment you plugged in, it's
Yeah, it came right on.
okay. Yeah.
Yeah, there we go. Okay, so that's
It
probably
might have
something with
drained
that.
out. You may
Yeah.
have to charge it.
Yeah. Oh, actually, yeah. So that's an empty battery.
That's
The
it.
blue is empty.
This one is probably has gone beyond certain point.
Yeah, and so it won't turn us on again. And this computer charger will give less voltage than
Less
that
voltage,
thing
that's right.
than that thing will. So let's
Use that one.
plug that one in. Yeah, and let's keep this one plugged in for a bit here, but we can run off of this one. We just won't be able to control from the computer. So we can start it and do our kind of initial stuff. So everything should be in the top, just like color coded like that. Settings, volume. Oh wait, keep your feet here.
Please check the volumes. I checked now my email and the
Okay.
actual number is 286.
286.07?
Yeah.
Okay, so let's
08 actually.
open. Just go here. I'll just change that. Sorry, it was 286. 286.07.
79.
79. Okay. Is it 079? Oh yeah, 07. Okay, there we go.
Yeah, thank you.
Okay, and then we're going to change the units. Flow we want. ECH, no, I want. Where's your units? This. English? No, yeah. Let's just go to meters and air changes per hour. Yeah. So you can give it to me. There we go. Yeah, now it's gone. Okay. So volume, now that we're in meters, we're 286. 286.079. There. Okay. So now the controller's set up to run individually without the computer. Do you want the results in meters or do you want it in CFM?
Meter.
Meters, okay. Which is one of the nice things about being here is that you don't have to really touch that at all. You can just plug it in and everything kind of shows here. But it's now set up to capture baseline. So we can do that and start there and just say capture baseline. And it'll kind of do it for us.
That's showing the current pressure difference.
Yeah.
So it's negatively pressurized.
Yeah. Which makes sense for being up a floor too. It should be the other way around actually if we're getting static effect.
But this is too small.
Yeah,
height.
it's too small, yeah.
And
It's
the pressure
very
is too
tiny.
low.
Yeah. So I'm going to manually enter numbers here. Okay, wind, we are inside. Manually. Alright. So our initial baseline, if we say end capture, is going to be minus 0.4. Minus 0.04. Okay. And we're using a DM32, a Retrotech 5000.
6,000.
Oh, sorry, 6,000. Yeah.
Mine is 0.4, not minus point
Oh, yeah. Is it?
0.4.
Did I miss that? Yeah.
Dude,
minus
which line?
0.4. Is that right?
Yeah, minus point
Oh,
0.
0. Yeah. There we go. That'll make a difference.
Yeah.
Yeah, always got to have the edit. And then there is a thermometer in my bag there, a laser thermometer, just to get our temperature. Over here. We are 20 degrees inside. 17 degrees outside.
So there is a thermal. Is there any thermometer outside? Or
No, I just measured it with my laser thermometer.
Okay. No, we don't. We'll get put in note of it. Sure. Smoke and laser thermometer.
Okay.
Take a picture of it.
All right, and okay, so we're ready to test. We've got our initial baseline with the fan covered, and now we're ready to uncover fan and and run a test. Now we don't really want to do any fixing beforehand. You guys want to just see it as it is, where it is, and then if we we can tape off the window or something and see. Okay. So I usually start with a high pressure. There's no, as far as I know, there's no rules about that though. In buildings where I'm worried about something like ripping off the wall, then I'm a little more conservative. But because we're pressurizing, we're going to be pushing against. I think we're reasonably okay here. So.
Do you do anything with internal fixtures? No. Do you check around?
No, it depends on what kind of test we're doing. So if we're doing like a passive house test, we close off all intentional openings. In the standard other test, like the Energuide test, it's as operated.
Okay.
So it's just kind of as is, where is. We just leave it. If obviously we close the windows if we can. This window we can't. But
the occupants, you ask them to move out.
No.
They can still function.
Yeah, and quite often we'll have trades working in the building too.
Okay.
And that's okay as long as the building is in lockdown, so that we can't go. We can be in or we can be out, but we can't be both.
Okay.
So while the test is running, and it's not a big deal if somebody goes out. It just messes with the data. So if somebody goes out, you'll hear the fan ramp up, and so usually we shut it down and do that number again, whatever that happens to be. So running the fan. So we'll go set pressure. And we can go, we'll start at like 55 or 60. We'll start at 55 just because we don't know what this building will do. So, which is nice, so we don't have to run around and find it. Okay, so we need a more stable thing. Since we've got the fuses right here, why don't we just try the fan here, and we'll leave the computer on this side. Let's just go to that one. That plug looks sketchy as all get out, but we'll see what happens here. Let's try that again. So we're actually, nice thing though is we're actually pretty close in the range, the guess on the range with ring A, because it was at, I think it got to about 75% fan capacity, and it was pretty close to 55. Yeah, so that's a good starting guess there, which means this building is leaky. Very leaky.
Surprise.
Yeah, so we did Charter Telecom with 4 dots open, right? So.
And the fan was not nearly going to.
No. so this is the induced pressure, and then the flow rate is what it'll do, and then it'll give us our calculation there.
So we intentionally change the pressure and measure the flow rate at that pressure, or the pressure already.
So right now I'll drop pressure again. So
Okay.
actually, sorry, I didn't record 35. So it's artificially creating the pressure difference. This is the pressure difference across the envelope.
Yeah.
This is the flow rate of the fan.
Yeah.
That's enough settings. I want to go baseline again. Clear baseline, capture baseline, and that covered. We have that cover handy still. The other one, the soft cover.
Yeah.
Maybe stick it in here. Here it is. There we go. So that'll take again at 0.3 this time. Okay. Okay, so now, because we took that manually, we need to save this. And do it again. So if we're running connected to the computer, that does this next part just automatically, which is kind of fun. Save
This
this
is
now.
not coming up, so let's connect this one.
Yeah, let's see if that works. Yeah, okay, let's try that. Let's see here, just because this will have a little bit of charge on it now. There we go. Okay, this is gonna be nice. You know, instead of running the next part manually, I'm just gonna run an auto test now because it is. That's okay, because the computer will give it some, but it won't give it a lot. Okay, so let's go begin an auto test. So it said just told me there, please seal the fan for the test.
Yeah.
I'm preparing for baseline test.
Yeah.
So it pretty much just orders you around now.
Okay.
So the manual there, there's a couple of problems with running it manually. Number one, it's really difficult to get a really accurate reading because it's just bouncing around, and which one do you pick, right?
Yeah.
And number two, you have to kind of do it twice because you got to do all your things, and then you got to run the calculation to make sure you got all the baseline in there, and you miss a couple, and all of a sudden your standard deviation is going to look like this. So for the most part, we run like this unless there's something like catastrophically wrong with our equipment, and then we go to the analog backup. So if we're doing an EnerGuide test, the analog backup is plenty accurate. For Passive House, I don't think it's accurate enough. Just because you get when we're down talking, arguing over like 0.1 of an air change, you really need that. You really need that accuracy. So and you can see it's now auto populating. It takes a whole bunch of baselines.
Yeah.
And then it'll start giving me orders again. This is also how you update the software on your gauges too. So you do need to be able to plug them into a computer every now and then to update the software and whatnot.
So Falguni, this is a lot of the gear that you guys have up at the school?
This is their
This
kit.
is all your stuff?
Yeah.
It's so
Mark's
shiny.
computer though.
Yeah.
Clean.
Yeah. I know. Let's get some drywall dust in
Yeah,
this.
I know. It's like,
Yeah.
it's like I'm gonna step on it a few times and make it look used.
Yeah.
We just bought it and we used it in the lab.
Yeah, okay.
We didn't put it in the field.
So the difference between this gear and my gear is that power supply, and it allows it to be a little more precise in how it measures and the amount of like the high and the low volume, and so it spins the fan faster.
Right.
This is the same. This is the same, but it's that's the fan's a little different as well, but that's the key difference. There we go. So unseal the fan. As long as we're following its instructions, it will do it properly for us. There we go, and then we can just stand back and watch. this is pressure difference, or pressure, pressure flow measurements. It's not actually the air leakage. When it finishes, it'll give us a calculation down here of whatever it is. But it won't tell us until it finishes. Keeps that secret. And it'll fluctuate all over the place anyways. You can actually see it on here if we change this number. Here. So that number is our air leakage at this Pascal, but at the higher ones it'll be way high. At the lower ones it'll be quite low. So one of the reasons I don't turn that on in front of clients is because at the low pressures, we're way better than Pascals, and at the high pressures it's a total fail. So I don't usually show clients that because it gets people excited about numbers that aren't real. So that's good. That's a wider range of fan because the 5,000 ones quite often don't go down that low. So the measurements get wobbly and they can't quite. Oh, there we go. Okay, so it's finished.
Is it checked or is
Nope, that's finished.
Oh, so
Finish the test.
Their power line can take it.
So it says, again, please seal the fan. So we need that cover again, and then. Say okay, and then it's going to take the final baseline, and then it'll give us a result. It does have a few error numbers in there, but we'll take a look at what that error is, and we can decide whether we want to keep that number in there or not. But it's given us what looks like 6 good numbers. So
1, 2, 3, 4 error numbers, and 1, 2, 3,
And
4, 5.
yeah, and those errors, like they could be, especially at the high level, it could be just because something's flapping around, like some damper is flapping open and giving it some weird result. Or, some other, like the wind comes up sometimes and you'll get errors.
So it can be external, internal.
Bird flying past the
Yeah,
window and
bird-
change the air pressure
that's-
inside the room.
That's right, yeah. Too many seagulls. So, there's a number of different things that could be, but usually if the error is under 5%, we, at least for Energize, we ignore it. And if it's, for Pascals, that might be a little more precise than that, but. So if you're on the other side, if you have the fan running the other way, you just put that back on. And the full cover to do the baseline.
Okay. So now, why do we need to cover it right now?
It's measuring the baseline, so natural difference between inside and outside. And so we
Did
can't
we
have the
already-
whole. We did one at the beginning, but because the wind could come up and the weather could change, we do one at the end as well. Or the building temperature changes.
Okay.
Quite often the building temperature does change because we've just pumped a whole bunch of outside air inside.
Yeah.
So one more after this one and then it's done.
Okay, so
Do you know anyone who puts those pressure gauges, differential pressure gauges inside and outside to find out?
Not in industry.
And,
Yeah.
do you know Kevin Knight?
No, I don't think so.
He's from Edmonton.
Okay.
And he's of Winnipeg.
Yeah.
So he suggested that we should put those things outside because there are now you're doing the pressure this side and this side.
Yeah.
But depending on the wind, there may be 4 different pressures.
Yeah, so they give you a set of hoses, I think it was in here, for that purpose. There's
Do you know how to install?
Yeah.
How do I put it?
a second set of red hoses in there somewhere.
Yeah.
Yeah, there we go. Okay.
So there are, yeah, so
Yeah.
three.
So that hose, what they've given you there is an extension and a T. So if it's really windy, what we'll do is we'll put the extension on and put the T on, so we can get two different. And we end up with the average, right? So you put one near the front and one near the back, or around the corner, or under a bucket, or something to.
So you basically go and put it under the door or something?
Yeah, and
We
so.
can extend it to, three sides.
Yeah, three sides of the house, so you get an average of the
But
whole place.
which open you put through?
This one still.
So you
Right
have
there,
to have,
so-
you have to put something on the door. Or you have to
You don't have to. I mean, you can put it through a leaky window or under a door sweep or something, as long as you're not squishing the hose.
But
So-
it will automatically, your software will record it.
Yeah. So, well, it won't. It'll record the pressure difference. So that red hose is into the red hose here. So if you want an average of the whole house around the house because it's a windy day, you put on the T's, and then it
They will
does.
collect all four of them.
It'll collect, but it won't collect them individually. It's just
No,
one measurement,
that's
right?
fine.
So,
Yeah, that's fine.
yeah.
We can do that. We have the T here and we don't have the T.
Yeah, we have the hoses, so there must be T. So so we can put it three. There are three.
That solves the
hoses.
problem.
You were really close.
Yep.
It's 23.2. Wow. So yeah, it's not bad, hey? So it gave us some error warnings up here, but the error in the end was only 1.3%. So I'd be willing to keep all those numbers. And the individual errors for each of them, the only one that has anything over, is that one. So if we wanted to, we could delete that one and improve the error, but it's really pretty good. So, the equivalent leakage area
Can I take a
is
picture from the result?
is 2,800 square centimeters. So that's not super small.
Not really, no.
It's not really that big of a suite. though.
It's not that big of a suite. That's an open window. Yeah.
Does it need the volume of the space?
So yeah, the two errors that it gave me at the end here was that it was missing floor area and envelope volume, so it can't give us a normalized leakage area. So if you have those two, you can put them in, and then it would calculate that too.
But can we download this data and put
I
those
can-
values and run it?
Absolutely, yeah. I can email this to you. And you can have, and then, so the nice thing about software too is that it gives it to you in pretty much any form you want. Once we're done a test here, the results summary. So it tells us whether we've complied with the standard, which right now I have it set to the GCSB standard. It gives you the warnings. You can do some quick graphs to impress people with graphs, and you can export the data to Excel or to a Word file, which has kind of like an auto report sort of thing in it. So it kind of quickly, can generate a report for a client or something like that.
Mark, I'm good to go.
Okay,
But this was fun.
good. I'm glad you enjoy.
Yeah, just
Scientific
standing around
testing.
and watching my hair fly back.
Felt good. Felt like you were driving a
I
convertible,
know.
When you
right?
came here, it's a lot of hair was
Yeah,
there.
I know. I had a full head of hair just earlier today. But yeah, so I gotta run. But are you gonna stop back at the office before you head back out?
I could if needed, but otherwise,
you
no.
don't really have
Yeah,
to. But
no.
yeah. Okay,
yeah.
good. We'll see you
Yeah.
again.
Thanks,
Thank you
Will.
very much.
See you later.
Thanks for
We'll see you guys. We'll see you.
Yeah.
Sure. Okay.
So the report you can put anything you want in the report from the data set, but it's there for you if you needed to quickly generate one. So I think if you want the data to play with, it's an export to Excel, and then it comes out here as a whole whack of data to play with. Come on. Okay, well, it's not going to give it to me, but it's going to, you can get it. And then, but yeah, I can save this for you, and then you can come back after and enter different things. You could change the results.
And
if
you can
wanted.
still run it again.
Yeah.
So if I put a wrong volume, okay?
Yeah.
Instead of 280, I put 200.
Yeah.
Then I did a mistake after the test, okay? I can change that one and run these calculations once again.
Definitely, and you can. So one of the things we've done is where they have actually changed the building, right? So where if we say, okay, well now what if the building was like actually half the size and half the volume, so you can use the same air leakage and just, I mean, it's not going to be as accurate because we don't know where the air leakage is, but
but you can kind of do that. Yes, you have the ability to change everything about it, and you can also come back and change the range. So, maybe somebody on site made a mistake about which range they were in, and you can change that. So you should be able to change all the parameters of the test, even the results too. If you look at that and say, well, what happens if we, did this, the results. So.
Okay. But the raw data which are recorded, those are protected cells, isn't it?
Yeah, it is. Yeah.
It should be.
Yeah, yeah, and so I can email you this file, and it'll have everything. You'll be able to open it in the fan software, and should be able to play with it.
Okay.
Do you guys want to run another test? Maybe close that window
maybe closing the window
and see what happens.
Yeah.
I've got the Bluetooth. We'll stand further away from it too, so we can hear.
Yeah, but if it's on yourself, it's easier to.
Is that gonna work? Check sound.
Yeah.
Okay.
Looks like it's working fine.
Is it important to seal all the windows in order?
In order, like.
Order the windows in
Other windows?
If there's big gaps, we could tape it off to see what difference it would make.
Do you seal, how you visually characterize which one to seal and which one not to seal?
So if I go to a building and I know that this door is going to be replaced, I'll usually seal it. If I know that one is not, I won't. Yeah,
and
so
you will not seal any of those things?
No, unless I know it's going to be fixed, right? So if the contractor says, oh, we just haven't got this window yet, or this window's broken, we know it's fine, then what we'll do is we'll seal it off because we know it's going to get fixed, so we want to eliminate it from the test. But yeah, and like in a building like this where we want to know what the difference in fixing that window will do, we do one test, seal the window, and then test again. So now we know what the difference it'll make if we fix that window.
And I think that's probably good for this building if
Yeah.
you want to say that, if we just fix this window,
Yeah.
don't have to do other things,
Yeah.
what are the differences?
Yeah,
Okay.
yeah. So, the other things we could do here is, like, there's no sweep here, I don't think. So if we tape that, installing door sweep or something like that, right, would also make a difference. Or weather stripping.
Okay, let's do a thing. Those are the obvious things. Okay?
Yeah, so.
This is pretty, people normally will not fix it.
Yeah. So if obviously, the window's pretty obvious you're going to fix that, so.
You never do anything with the skylight.
Well, usually I can't reach the skylights,
Because
so.
skylight normally what happens, if it is leaky,
if-
water will be more dangerous than the...
That's right, yeah.
So if it is not leaking, water problem is not there, I
That's
think
right.
nobody will touch it.
Yeah, exactly. Okay, so we are ready to go again. Everything is covered, so we're going to begin the auto test. And we'll search for the gauge. It's found the gauge. It's telling me to cover the fan, which we've already done, and then it'll start running. There we go. Okay, so the test is running again.
uncover the fan?
It's still doing the baseline. So the software is very demanding. It'll pretty much order you around and tell you what to do, and it'll tell you when you've done something wrong. So it's kind of nice that way. While we're waiting for that, did you get good video on how this was actually connected?
We can take some more.
Do you want to just do a description with the
Yeah, sure. Why not?
how we actually did it?
I think I did get some video.
Yeah. So it's color-coded wires to when we're inside. If we're assuming we're inside, color-coded to color-coded. If we were outside, because we had to be outside, then the red would go to the blue.
Okay.
And then on this particular fan, yellow connects to yellow down here, hose, and then out to the fan here. And then it should be in the in because we're controlling. So this side, it goes in the control side and then to the in. And then the one at the bottom here is if you're networking.
Okay.
So if you've got multiple fans, that's what that is used for. So then you would connect to the other controller and then to your computer. I usually, when I'm networking two fans, just because it's an easier network to set up, I usually use the USB. And then actually this one here, which has, so just a USB hub.
Okay.
There we go, fan is ready. And then it's just an easier network to create than the Ether network. So, just it's a little faster.
So I can use this for one fan and this for another fan if there are three fans?
You could, but it would be probably easier for you to get a USB hub with three.
Yes.
Or use like a network router and just use the one, so you're only using one connection method. So if, most of the time we don't have enough USB connections to do more than two, so we'd go to the network cabling for the other methods, and that way you can run longer cables because the Cat5 cable is a lot easier to run 200 meters out to the next fan. So in a like in a big multi-family, we might have one fan like 4 stories high, or one fan way over here. So then we need to run to the network because we can have like long USB cables are difficult to get. So, and then the controller can sit at the fan and run back to the central network hub. All right, so we're ready to go. It's going to start up.
Possible to use both controllers at the same time?
The fan and the computer, or two?
In one computer to gain accurate result.
Yeah, so that's how it, when you're running a multi-fan test, that's exactly how it is. So there'll be a master controller that is running all of them, but on each fan has its own controller, and because you need the controller for the sensors, and so the slave controllers will report back to the main controller what their readings are, and the main controller reports back to the computer. So that in that way, the fans can run at different speeds, especially if you've got a compartmentalized building. It needs to run, like, the smaller unit needs to run at a lower speed. They're not all trying to run at the same speed. You can, on the 5,000 fan, this one you should be able to do it as well, because the out on that is used when you've got two fans basically in the same door. And so they're right beside each other, and one fan is just for extra power. It's not a sensor fan, and so they will both work at the same speed then. And so maybe really big building or really leaky building or something. That's what that double stacked fan door is for, and that's what you use that connection for. So they're not running at different speeds. We're not seeing that same error yet, so this test might get a little, we've removed the flappy, whatever's flapping around. Good old tape.
I don't think so, it got opened.
There you go, okay.
That tape is too thin.
Yeah.
So it's not going to take that.
It's always a balance between using a really good tape that'll work and won't rip the paint off and piss off all your clients for ripping their paint off, right? So, is this one stayed? Oh, this one ripped off too. Yeah. Do you want to stop the test and we'll try again? There we go. It's just because we.
You never see those.
Oh yeah, we could seal that too. That's probably not a bad idea. That one might work with tape, but these other, I don't know. How are we gonna? We need something bigger in there.
Maybe 4 layers.
Yeah, 4 or 5 layers might get us there. I've got some Sega tape, but that will rip everything off. So I don't want to do too much damage. Let's just see if we can take to the glass here. This is such a hard angle to do. See, I wonder. I can't just close this window. I wonder if we could do that from the outside. If this window would actually slide.
We couldn't go out because we set everything here.
Yeah, well, we can. There's a trick. So, yeah, there's a little dog door here. So if we just put that there.
Still capture with camera, don't worry.
So if it goes wrong, there's evidence? Yeah. No, I think I might be able to tape it better from out here though. Maybe it'll take most of a roll of tape, but
Cannot do anything about that.
oh yeah, we definitely can. Let's just. Yeah, you get the bottom one.
Take care of the partition.
Some of the high pressures might just rip that tape off, but get us started.
Let's see. There is no special tape, it's the regular blue tape you put.
Yeah, well, we use this because it doesn't rip paint off, and so when we're in new construction, people really don't like it when we rip their paint off, right? So
It's the same thing for you. You can ask to Canadian Tire or Home Depot that
yeah.
give me a tape which does not rip off the paint.
Yeah, this one we found is kind of a good balance between wrecking paint and having an actual seal. We have some green stuff, but that stuff's not as good. It's not as
This one is
sticky.
a good one, huh?
It's a little bit better, yeah.
Okay, what did you take against it?
It's a little bit better than that green stuff. The green stuff doesn't really stick very well at all.
You buy something, because otherwise-
And then there's some other stuff which sticks a lot better, but it can it rips paint off from time to time. So people get quite
We'll
upset
buy
with
this
me.
one, that would be good.
It's the European brand, right?
Yeah, that's Siga. That's the air sealing tape, the good one. So that one will take the whole wall off, not just the paint. I carry some of that just for when we're doing construction blower doors, and then we can put it on the actual air barrier, not the finished wall.
Okay, so you can start the test.
Yeah, it's just doing the baseline still.
And one question, so can we start this test, rather than from high pressure, from low pressure to high pressure?
Yeah, and you can kind of do it however you want to, and you can control it on your own too. If you wanted to set the pressures it goes through, so if you had a specific set of pressures you wanted to do.
For the sealing issue, I think that will be better if we start from low
And go high?
Go high, because we will make sure that the seal stays.
Yeah. So why don't we do that right now? We can change that. So to do that, you do a semi-automatic test instead of the other button is the automatic.
Okay.
And so we've already collected the baseline, so we're okay there. And then I can take this off. And then it gives you the options here, so we can choose fan speed or target pressure.
Yeah.
And we're going to do
lowest
building pressure. So if we started at say 20,
Yeah.
and then we don't need, we can run for 5 seconds. And we run the fan there. And so it'll say beginning, and it'll say seeking pressure, and then when it says pressure attained, it'll let you collect the data point. And so you can choose how long it collects data points for. So with pressure attained, we'll collect the data point. And then it'll read for a few seconds. Data point complete, and then we'll go to 25, just like that.
So we are doing it manually, like
Yeah.
entering the pressure manually.
Well, I'm changing the fan speed manually. But it's not as manual as entering here. So we've still got the computer collecting the good data, but all I'm doing is I'm driving the fan without it letting it run automatic. Oh, somebody opened a window.
Yeah, Falcon even.
Oh, okay. So that's how you know somebody opened a window, is because the fan just starts going crazy, or something broke, or.
Let me check.
Oh, I sealed the door. Now we have to do it again.
Oh no. Yeah. Oh, he was just going to deal with his parking, wasn't he?
Yeah.
Yeah. Okay. Well, he'll be a little bit. Hey, we can capture a few more. Yeah, we can capture a few more points here. Tape actually does seem to be holding so far.
Yeah. Starting from a door is a good idea.
Yeah, when we're relying on cheap tape. Yeah, yeah.
go from down to top, you have to collect the data.
Yeah.
Otherwise it's automatic.
Yeah, it's not automatic that way. I'm sure there's some way to switch the program somehow. I don't know how to do it, but this is a pretty easy way to do it. I just have to tell it when to collect the data.
And what is this corrected flow?
So it's doing, it's correcting based on the standard deviation and stuff, and the variation in the wobbliness.
So this one we have to read the corrected flow, not that
Yeah,
total.
that's right. Tape is still on there, actually. Huh, see how well that goes. Yeah. We'll do this as the last measurement here. We'll set the fan speed to 60, and then. The last measurement here, and then we'll do the baseline again. There we go. There we go. So I'm just collecting baseline here. Okay, so let's see what difference that made. Now we say calculate. Oh,
17.
yeah, quite a big difference, 17.99.
Yeah.
Our errors are nice and low again, so it's a good test. Well, that made a big difference.
Yes.
Yeah. Yeah. There we go. Yeah. So,
Your team
that's-
is ready for the next
did you guys want to test anything else before we close it down, or is that pretty much the test you guys wanted to run?
for the next step.
I think that's.
Yeah.
For September.
Oh, yeah. Well, yeah, more or less.
Yeah. So I'll be able to email you guys this data set, and you guys can play with it and do kind of whatever you want to do with it. And yeah.
But our plan is to make it around the 5.
Oh, okay. Good luck. Yeah.
But we have
Well,
one way to.
Yeah. So I mean, we can assume that the dampers in like the furnace and stuff are probably pretty terrible. And we know that there's pretty big leaks around here, and we also know that our tape probably isn't holding 100%. So
Windows sealed or no?
no, not really. And so we know that replacing the windows, probably at least putting thresholds on the doors, and stuff will have a pretty significant effect. Probably there's something in like there, right through the ceiling.
Yeah.
Just dealing with that in very inexpensive drywall fixes will probably get it down, and then a new floor. It might get to 5. Might.
It doesn't have any insulation in the floors.
No.
There is nothing.
Yeah, but it's tempered space below at least, so it shouldn't be too much of a cost. I mean, there's probably no insulation in the ceiling either, or in. Well, we know there isn't because this is brick here.
Yes. Plaster and brick.
Plaster and the brick, yeah.
The walls also.
Yeah, there wouldn't be any.
Yeah, maybe we have to pressurize the other.
Yeah.
neighboring walls.
Yeah, so in order to do that, we need 1, 2, 3 other blowers at least, And so then we go to the network. So it can be done. It's just a big hassle to notify everybody, right? And get them to do it. So yeah. All right. Well, if we're done, then I guess we can put the toys away and go play with the data. So that should be shut off first usually, and just there because that cools down, and then we've removed power from this guy. Oops.
17 right now is at 50 Pascal.
Yeah, so 17.99 was the end result, which is, significant improvement over where it was. And